is from Weikang, who's a grad student from from Washington University in St. Louis. His PI is Camilo Padova Shiopa. Hope that's all right. And yeah, I'm excited to hand the stage to Weikang to talk about economic choices with simultaneous or sequential offers rely on the same neural circuit.
Okay, so I get started. So hello everyone. It's my great honor to present my work in this special conference. So the topic today is economic choices with simultaneous or sequential offers rely on the same neural circuit. So our lab studying neural economics. So we study behavior of making decision between two options. Imagine you're working. So one daily example is like choosing between food options. Imagine you are in a restaurant and you want to choose between two pizza options. One is pepperoni pizza and another one is cheese pizza. So you see the pictures on the menu and you want to ask yourself which pizza do you want. So in this case, the two options are presented to you at the same time. However, nowadays, because of the pandemic, you cannot go to the restaurant. We cannot go to the restaurant. So the way we make order is order online. So maybe you take up your smartphone and look at the apps. At first, you see your first option, which is the pepperoni pizza. And then you see another option, which is the cheese pizza. And maybe at the bottom of the app, you're going to see a question, which pizza do you want? So in that case, the two options are not presented to you at the same time. They're presenting to you in a sequential way. So our lab or this project is trying to answer this question. So we want to know whether the same neural circuit mechanism is shared by both task modality. So in the following talk, I will refer the sequential offer task as task one and the simultaneous offer task as task one and the sequential offer task as task two. So we use non-human primates, so we have to design a task for monkeys to do. So we designed a task that we have both task one and task two interleaved together. So the structure of task one simultaneous offers look like this. The monkey first fixes at a fixation point, and then in the queue time window, monkey will know what task it is by looking at the shape of the fixation point. And during the offer on, the monkey will make decision. During the offer on, there's two visual stimulus associated with two options will be presented to the monkey. And after the go queue, the monkey will reveal a decision by making a card to the target. So this is a juice quantity quality trade-off task. So we use different color to represent juice type, which is juice A, apple juice, juice B is peppermint tea, and different number of squares to represent juice amount. So this is for task one. For task two, sequential offer task, the structure look like this. Monkey first fix at fixation point, and then the queue time window will use another shape as a fixation point so that the monkey know what task it is. And we have offer one time window. Monkey will know, we will present the visual queue associated with the first offer in the middle of the screen. And in the interoffer delay, there's nothing. And during the offer two time window, the second option will be presented. And after wait and delay, monkey will reveal the decision by making card to the target. And we have both, we can have A presented first or B presented first. So we have A, B, and BA trial. And we interleave trials from all these conditions randomly, so they're randomly interleaved. How about the result of behavior and neurons? So first, let's look at the behavior. Our behavior analysis is done separately in task one and task two. So because this is juice quantity quality trade-off task, so we're expecting a signal curve like this. So the signal curve is fit by a probit fitting, and the formula is written like this. And also because we look at task one and task two separately, so for task one, it's only this part of this formula. And from this fitting, we're looking at two measurements mainly. One is the relative value, which is measured as this, which is basically the indifference point of this signal curve. It's measuring the relative value between juice A and juice B. The second measurement is stiffness, which is beta 1 basically from this fitting. And that gave us the behavior variability of this signal curve. So that's for task one. For task two, we actually look at A, B, and BA trials separately. the AB trial and BA trial, just remind you, refer to the order of Drew's presentation. If A first, that will be AB trial. If B first, that will be BA trial. And we look at relative value and the stiffness as our two measurements. And we also have another one, which is called order bias, which is defined like this. This is basically the measurement of those two colored lines, the distance between those two. And we call it order bias because the distance is actually reflecting the monkey's behavior, which is the order bias in favor of the second option in task 2. And why I said that, from this result, you can see the red line is on the left side of the blue line. The red line is AB trial, and if it's on the left, means more B is chosen. And in this case, B is the second option. So in this case, monkey has chosen more B in AB trial, and the opposite idea can be applied on BA trial. Therefore, from this single session example, you can see the bias is in favor of the second option. And another effect you may observe from this is the difference of the stiffness between task 1 and task 2. Task 2 has smaller stiffness compared with task 1. And that makes sense because maybe task 1 is easier for the monkey to do. So that's why the stiffness is higher. And such effect is also confirmed at the population level. We have 2 monkeys. This is example sessions. So first we look at the relative value difference. And you may notice that they may not different very much from the example sessions, and that may be the case. The statistic is kind of significant, but you can see the difference is not very much. So we tend to think the relative value may change, but not dramatically. But for the stiffness, as I mentioned, task 2 have much smaller stiffness compared with task 1. And we also observe a significant larger than 0 order bias, which means it's in favor of second option. And I didn't tell you what's our implication of that. It's actually quite easy because the order bias is in favor of the second option. Second option maybe have better memory or have less have less temporal discounting. So that's why monkey tend to choose second option. So how about the neurons? So we do a recording from orbitofrontal cortex, which is defined as the cortex in the middle of middle orbitosulcus and lateral orbitosulcus. So it's the purple, I'm sorry, I think it's pink part here. And we mainly record it from 13M here. And this is the bottom side of the monkey showing you the same thing. And we have more than 1,500 neurons recorded, and we mainly focus on 1,100 neurons from them because we define them as task-related. I don't have time to explain what is task-related, but we are just defined as task-related. If you want to discuss, maybe we can talk about it after the talk. So for the neuron analysis, we actually similarly do analysis separately for task 1 and task 2. So for task 1, this task structure actually has been studied very well in our lab. And our main finding from this is that we found 3 types of neurons in OFC. And those neurons are functionally different. First, we found some neurons tuned to their firing rate to the value of only one juice type. This example is the neuron that tuned to the value of only juice B. So we call it alpha value B cell. And the second type of second type of neuron is a binary encoding neuron. And this neuron, the firing rate is tuned to one of the juice type. And the third one is the chosen value cell. These neurons tune their firing rate to the value. It doesn't have information about the juice type. And we can also have A-related neuron similar as alpha value B cell and chosen juice B cell. And also we can have positive tuned neuron, which are like this, and negative tuned neurons. Therefore, in total, we can have 8 cell types. And those 8 cell types already covered a lot of neurons in OFC. And by having those type of neurons, you may have an idea. I mean, we actually have that idea that a decision circuit may be in OFC, and the structure may be like this. For the alpha value cells, they are maybe feeding the input to the decision network because they have both information about value and juice type. And for the chosen juice cells, because they are binary encoding neurons, so maybe they are projecting the output from this decision network. Therefore, to answer the question that whether task 1 and task 2 are sharing the same neuron circuit, one way actually is a way in this one is that to identify whether we have a we can identify a decision network like this in task 2. This work has been preliminary done in another study, which only have task 2 in that paper, which is here. What we found here, what we found in that paper was that we first found neurons in different time window are tuned to different things in task 2. That is not the case for task 1. What I mean is when we only look at the 3 time windows, post-offer 1 time window, which is this, post-offer 2 time window, and post-juice time window, we found those neurons are tuned to different variables. However, those variables are actually not random. They are associated with each other. And we call them variable sequence because the variable appeared in a sequence, in a temporal sequence. And only 8 of the variable sequences are really tuned by those neurons, which I present here as a table. And you can see the number 8 match the finding from previous one, the task 1, and also it is explaining many neurons as well. So what do I mean by this sequence? To explaining that, I think a better idea is to show you some example neurons. So here I'm showing you one example neuron that is from the sequence number 3. This neuron first tuned to the offer value B in BA trial only. This is the tuning curve, how the tuning curve look like. I missed the y-axis. The y-axis is firing rate. Here, different color represent different trial types. Blue is BA trial, red, which is written here. I hope you can see. And red is AB trial. So because it's tuned to the BA offer value B only in BA trial, so all the red one are assigned at 0. And so that's what I mean by the variable offer value B in BA trial only. However, this neuron tuned to the offer value B in AB trial if we look at the post-offer 2 time window. For the post-juice time window, you can see this neuron are tuned to the chosen value B. So this neuron actually tuned to the value of juice B whenever B is presented like this, and whenever B is chosen. So this neuron's tuning property resemble our offer value B cell. The second example is another binary encoding neuron. It first encodes the juice type or the trial type AB or BA, and then for the post-juice time window, it is encoding chosen juice. So this neuron resembled our chosen juice cell maybe. For the third type, it's a value encoded neuron. So it's encoding offer value 1 first in offer 1 time window and offer value 2 in offer 2 time window. And it's encoding chosen value in post-juice time window. It has no information about juice type. It is resemble our chosen value cell maybe. So similarly, we can have A assigned neuron, and we can have positive, negative assigned, tuned neuron. That's why we can have 8 sequence type in total. And let's move back to this. As I mentioned, those neurons resembled what we found in task 1. So that basically means maybe our circuit is true as well in task 2. But we also want to further explore that. If that we want to know whether it's not only just true, it's also have a 1-to-1 matching, which means one neuron defined as offer value B cell is also somehow offer value B cell in this case as well. From the single neuron example, my answer is maybe yes, because those neuron examples shown here are actually exactly the same neuron as I showed you in task 1. However, we need to test this at the population level. To do that, so the question is whether the cell classification from the 2 tasks, task 1 and task 2, are correspond to each other. To do that, our hypothetical analysis is to make a contingency table look like this. So in this table, each element is a number, which is a cell number, and the number means how many neurons. For example, this one means how many neurons are classified as offer value A cell in task 1, and also encoding sequence number 1 in task 2. If there's a 1-to-1 matching, or I can say the classification is corresponding, we're expecting high numbers only along this diagonal line. So here's the result. From the raw data, you can see the diagonal line have pretty large numbers as well, but this number cannot offer us statistic power. So to do that, we translate this contingency table into an odds ratio table. The odds ratio is done element-wise, which means this odds ratio means odds ratio from this. And the odds ratio is telling us if the odds ratio means, if the odds ratio larger than 1, which means the number shown here is above random level higher than other elements. So what did we expect?
We need to wrap up in a minute, very soon. Please finish.
Okay, so basically the point from this plot is just showing you that the diagonal line have above 1 and also pass the Fisher exact test, which match our hypothesis. So perfect timing, I guess, kind of. The last slide is the conclusion. I show you at the behavior level, task 1 and task 2 are similar in terms of relative value, but task 2 is different in terms of stiffness. In terms of the neurons, what I've shown you that is the same neuron circuit might be adopted. And last, I would like to thank everyone in Camilo's lab and our funding resources. And here's our Twitter and email. So please feel free if you have any other questions.
Yeah, thanks. Oh, sorry. Thanks, Weikang, because
thank you very much.
We are about to be kicked out in like 30 seconds. So I just want to wrap up soon. We probably don't have time for Q&A because of the long presentation, but people want to discuss
sorry about that.
That's why people want to discuss with Weikang or all the presenters here. Just follow their Twitter, continue discussion on Twitter with hashtag NMC3 as well. So yeah, I think that's basically the end of session. Hate to finish and wrap it up so rushly, but yeah, but still thank you very much for all the presentation and all the presenters today for the session, and thank you for the participation. And also for the participation from the audience. Okay, yeah, that's probably the end of the session, and have a good night or have a good day for whenever time zone you have. Thank you. Bye.
Thank you.